So good news, guys, you won't need graph paper for this one. I would like you to write an equation of a cubic function that has been vertically stretched by a factor of 5, shifts left 3, shifts down 2, and is reflected over the y-axis. So if you remember, a vertical stretch is my A. A shift left is going to be my H. A shift down is going to be my K. And that new one, reflected over the y-axis, is going to be the B. So if I put this all into an equation, I'm going to get y equals A x left 3, so I'm going to add 3. I'm going to shift it down 2, but then the B is going to reflect me over the y-axis, so I throw the B in there. Okay, now let's write an equation of the cubic function with the inflection point of 3, 2, so I know automatically that that would be h and k, and goes through the point -1, 7. That should say point in there, and we're going to label that x and y. So I'm using this form, f of x equals a x minus h plus k. So if I just start plugging in everything that I have a y, I don't have an a, but I have x minus the h cubed, and I have a k. Now I'm solving for a, just like we've done in the past. So this is going to be -4 cubed. I'm going to add 2 to the other side. -4 cubed is -64. And if I divide both sides, that will not simplify, so a is going to be 9 over -64. So my final answer is y equals a x minus the h cubed plus the k, but it's a -2. And if I were to put this into y equals, I would then be able to check to make sure that that point and that point are in there. And I technically should probably write that as f of x. What if we had something almost the same, except this time I'm using the form b x minus h cubed plus k. Well, that means I'm looking for b. So I still have the same thing. Inflection point is hk, and this is still xy. And when I plug everything in, I'm going to have y equals, but now I don't have b. I have x, I have h, and I have k. I'm going to subtract 2. And 2b cubed is 8b cubed. I'm going to divide by 8. And if I take the cube root of that, make sure to put 3 in here for the cube, I get -0.956 to be my b. Now, I did randomly select these points, but that's still a weird number, so I'm going to check this in y equals. And that actually works. So my equation is going to be y equals -0.956 x minus h all cubed plus 2. Now, When I checked this as y equals, I did not put that into y equals. I actually put the cube root of negative 7 over 8 in here. Okay, this will be a little off probably, so if you want to check it, put this in as your b and type it in, and it goes through those 2 points. Okay, so now let's write an equation of this graph that has been transformed so the inflection point is on the y-axis and it goes through these 2 points. Notice we're not going to be able to use h and k because we don't have an inflection point. Also, if it doesn't mention which form to use, we're always going to be solving for a and not b if it doesn't mention. So we know that we're going into the form y equals a x minus h cubed plus k. So what are we given? So we're given an x and a y twice. So you know that means we're going to have to write 2 equations. This is going to be a lot like the quadratic one. The problem is, what does this information tell me? If the inflection point is on the y-axis, so that would mean all of these points could be my inflection point, and they all have one thing in common. Their x is 0. So and if the inflection point is on there, I know that means that h is 0. So I know my h is 0. So I'm now going to plug in the first point, and I'm going to get y equals a x minus h cubed plus k. I'm going to get 3 equals a 4 cubed. That's going to give me 3 equals 64a plus k. I'm going to do the same thing with the other point. So y equals a x, whoops, my x is 0 minus my h is 0 cubed plus k. What does this do? This gives me that k is going to be negative 3, because right here 0 cubed is going to be 0, and 0 times a is 0. So k is going to be negative 3, which makes it really nice. So I know that k is going to go into there. Now I'm just going to solve for a, and remember, all I need to do is take this k and plug it in here to that k. So I'm going to get 3 equals 64a plus k. I'm going to add 3, and I'm going to divide by 64. When I divide by 64, I'm going to get 3 over 32. So now my final answer is going to be y equals a x minus my h, which is 0, cubed plus k. And I really don't need the parentheses on that, so I'm going to do y equals 3 over 32 x cubed minus 3. That's a terrible 3. So my last example is to write the equation of this cubic given the 3 x-intercepts and a y-intercept. So remember, if I have an x-intercept of negative 2, that would go into the factor of x plus 2. This 1 would go into the factor of x minus 1, and this 4 would go into a factor of x minus 4. And if I multiply all of these out, I would actually end up with an x cubed. So I have a cubic. So again, we're going to be looking for a. We don't know what a is, but I do have the y-intercept, which is 0, 3. So this would be an x and a y. So again, I am going to use what's called intercept form because I have my 3 intercepts. So I'm going to write it like this. I know that y equals a x plus 2, x minus 1, x minus 4. I know this is my x and y. So now everywhere there's an x, I'm going to plug in the 0. and every time there's a y, I'm going to plug in 3. So I'm going to plug in 3 equals, I don't have an a, but I have an x, I have an x, I have an x. And I'm going to now do those parentheses, so that's 2 times -1 times -4. This is going to get me positive 8. So a is going to be 3 over 8. So my equation is going to be 3 over 8 times x plus 2 times x minus 1 times x minus 4. And I'm going to leave it just like that. I'm going to change this to f of x. And if I was asked to put this in standard form, I would multiply this whole thing out, but I'm going to leave it just like this. I will see you tomorrow.